Hi, everyone. Welcome to this evening's talk evening with PyLadies Berlin. Really glad to have you join us this evening. We've got a great schedule lined up. We'll first start with these community introductions. Then we'll dive a little deeper into exploring our community with myself, and we'll be going over some of the recent survey results that we did earlier this year. Then we'll move on to a talk from Doreen about reproducible machine learning projects with DVC and Poetry. And after that, we will have a talk from Prad van Dicht about Python's tale of concurrency. Really excited to have you join us this evening. We're streaming now live on Twitter, on YouTube, and on Twitch. And we'll also have a recording of this evening's session that you'll be able to find later on YouTube. So if you're not familiar with PyLadies, we're a global organization, and our mission is to promote, educate, and advance the diverse Python community through outreach, education, conferences, events, and social gatherings. PyLadies itself is an international mentorship group with a focus on women becoming more active participants and leaders in the Python open source community. PyLadies is also aiming to provide a friendly support network for women and a bridge to the larger Python world. Anyone with an interest in Python, though, is encouraged to participate and then join us. We do have a code of conduct. So while we believe knowledge is for all, and at the same time, these events are aimed primarily to empower women in the tech community. So by agreeing to attend one of our events online or in real life, you're also agreeing to our code of conduct. PyLadies is dedicated to providing a respectful, harassment-free community for everyone, and we do not tolerate harassment or bullying of any community member in any form. You can read the full version of the code of conduct on this link. And if you feel that you have observed or have been part of any behavior that you feel breaches this code of conduct, then please do reach out to us. You can reach out either to myself via Slack or one of the other organizing team, or you can send us an email at berlin@pyladies.com. So why not get involved? Of course, it's not only myself. I would like to introduce to the stream now Uke, who has been helping me with organizing this event for you, along with a few other folks. And there's many ways that you can get involved. You can give a talk or workshop, like you'll see Doreen and Pravan do this evening. You can help organize a meeting, like Uke has done this time. You can be a coach at one of our workshops, or you can join the broader organizing team and participate in such fun tasks as getting sponsorship money or answering emails. Maybe that's not a hard sell, but I do find it incredibly rewarding, and I hope that this will lead some of you to consider doing the same. And we have some really great meetings coming up, not just this one. So on May 22nd, and 5 days, we have Algorithms and Data Structures Study Group. Then on March 31st, we're going to have our open source hack evening. This is in person at the Back Market office. And on June 19th, we will have another set of online talks, which will be similar to this. And the details for those will be coming up shortly on meetup.com. So before we disappear, please, at the end, do fill in our feedback form, which we will try to remember to put in the feed. I must honestly say I've forgotten every recent feed to do so. So I will try my best to remember to do that. And if not, we'll post it in the YouTube channel later. And you can also register as a member of PyLadies. So official registration means that you also get to vote in the Global PyLadies Council. And also get to have your voice within the global community. So I really recommend doing that. If you're not on our Slack, please join us on Slack. You'll find the sign-up details on our meetup page. Also recommend following us on Facebook and Twitter. And if there's other places you think we should be, let us know, and we will try to find you on those platforms. Okay, I'm going to say bye to you now, and I'll dive into the deep dive of the community. Thanks for joining me.
Thank you, Jessica.
Sorry. I'm a bit too quick on the button, so my apologies for this. So, PyLadies Berlin, who are we? Founded in 2013. So, we'll be celebrating 10 years next year. It'll be a big milestone. We hope you'll all celebrate with us. Currently, we are 2,253 members strong on meetup.com, which is quite amazing. We've got 4 chapters in Germany, and this is slowly growing. At the start of this year, we decided to run a survey to try increase our community outreach and see what we could do to make our community efforts better for everybody that is part of this community. But of course, we can't do that alone. As a group of organizers, we're a subset of the entire community. And while we do our best to put into action the things that we think are most beneficial, we really need your voices to help lead this. We believe that the best community activities come from the community itself. And as I mentioned, while our dedicated org team love putting together events, we really rely on you to inform our decisions and support the community. We also want to reach even more members, helping them with their coding journey and whatever stage that they may already be at. I think it's great if they can join our community and be part of it. So we had 39 respondents for the survey. And I think this is quite good considering that, well, first of all, we've just had a rather tough 2 years of a pandemic. And this has meant that a lot of people have been very fatigued for being online. So I also appreciate everyone coming online to join this evening. But we realized that members like to engage with us the most via Slack, then meetup.com and Twitter. So Slack is really our stronghold. So if you want to talk with more community members, Slack is the place to be. Most of the respondents were based in Berlin, but actually, interestingly, 23% were not. And even one of our speakers this evening is not in Berlin. So I think this really shows you how much we can do when we're remote or hybrid and what a broad reach this community can have. What I thought was quite interesting is 65% of the participants use macOS, while only 16% are Linux-based, and we even have 11% that are on Windows. So we definitely need to ensure that we're very inclusive when it comes to different OSs. We also have a range of people who have different experiences from with Python itself. So we have like a large chunk of people who are keen to learn. We have some folks already learning. And then we have people who are already working professionally with Python in maybe what we would call the early stages of their Python career in the 0 to 3 years range. And then we have quite a lot of folks, almost 45%, who have been using Python professionally for 3 years plus. The top graph here is the group joins. And I thought this was also interesting because you can see we kind of have steadily more and more folks joining this community. But we've recently had quite an uptake in new joiners. Respondents were most looking forward to intermediate workshops, followed by hack evenings, mentoring program, project run through, and interviews with community members. So these are some of the events that we'll look into putting in place. And if you have any ideas for them specifically, this is what the community are saying they would like. The top topics folks would like to see are data science and machine learning, contributing to open source and data structures, with IT security following close behind. So if we have any IT security professionals watching, then please reach out to us. This topic I personally know nothing about, so it'd be really interesting if there's anybody who can lead a workshop on this. For foundational skills, community members would really like to know more about salary negotiations, career navigation, and managing conflicts at work. Also incredibly important and interesting topics. So if there's anybody watching who also could run either one of our non-coding superpowers, which is this lightning talk slot that we have at the start of our meetups, that would be amazing, or even perhaps as a longer session. When it came to how to contribute, most folks were interested in coaching and workshop leader, as well as being a mentor. And when we asked you what help you needed, you told us that it was information on what it required. So watch this space. That's something that we're definitely going to work on to ensure that as many folks as possible can get involved in organizing. We also asked if you had one goal for 2022, how could the PyLadies community help you achieve it? So some of the goals were finding a job, using Python at work, building confidence, feeling inspired, meeting people, and side projects. I think these are all things the community can help with and things that we'll try to focus on this next year. What would you like to see happening in the community? We heard from you advanced material, open discussions, beginners group with tutors, in-person meetings, connection with companies, collaboration with other German chapters, and a central place with event logs and links. For the latter, we actually do have a resources directory or a repository, on our GitHub, and we will be sure to talk a little bit more about that and make it more transparent for folks where they can find this. And finally, but not least in any means, we asked for a kudos round. Who do you want to give a shout out to in the community? And these are the names that you gave us. We're really proud to have these folks in our community, and we really want to shine a light on them and celebrate their work and everything that they're doing. So thank you, Mariella. Thank you, Katiana, Emily, Mika, Meli, Noah, Paloma, Lace, Ellen, Shaskova, that's Lisa Shaskova, Jessica, which is myself, Maren, Mariana, Heike, Teresa, Ellen, and Victoria. It's really amazing to have you part of the community. And of course, these are not only folks who are shining in our community, it's also all of you. If you didn't have time to fill in the form, then please go ahead and you can still do so. We'll still take your responses. And if you have folks you want to give kudos to, we'll also tweet them out on our Twitter account. Thank you so much for listening. And if you have any questions regarding this, the best place to direct them would be on our Slack. Okay, so now we are going to have our other two talks, and I will also post the Slido in the comments. So if you have questions for Doreen, people can ask them on Slido. And I hand it over to you, Oka.
Thank you, Jessica. Hi, everybody. Welcome. Now we have 2 talks scheduled. And first, our first speaker is here, Doreen. She is a data scientist at OpenArray, and she's going to talk about reproducible machine learning. Big round of applause for her, and enjoy the time.
Thank you very much for the nice introduction. And thank you, Jessica, for the really nice insights. That was really cool. Welcome to my talk. I want to share a bit of my experience on how we set up projects in my company and kind of the tools I really like, which are DVC and Poetry, and they're useful, in my opinion, for reproducible machine learning projects. All right, maybe as a quick introduction, this is me. I'm a data scientist at OpenArray, and as you can see in this little nice animation, what we do is we have polls in news articles. So here you have a poll, and you can vote on it, and it's nicely integrated. Then I might want to tell you about my worst nightmare, and that has to do with my job. So my worst nightmare looks like this. So I'm a data scientist, and I work professionally with Python and for fun sometimes, but sometimes it can be not so fun. So sometimes you have Homebrew installed, and you have Anaconda installed, and you have Python versions installed, and you have Python 2 and Python 3, and you have pip, and pip doesn't know where you were, which was, yeah. And then it looks like this, and then you cannot upgrade anything, and if you do upgrade anything, it will break, and everything will be broken, and you will need days and days to fix it. All right, so this is basically my motivation for this talk. So we have, in my company, we have 4 services that serve machine learning models in production. And as you know, these machine learning models, from time to time, they need updating, and from time to time, they get outdated. So the 4 models were initially not developed by me / my current team. And one of them we realized wasn't doing so great anymore. So one of the models was trained pre-pandemic and it didn't know anything about Corona. And since we work with news articles, that seemed quite important to update it. However, we couldn't build on any of the work of our colleagues because the project there was no documentation about it. We had no idea where the training data was. We found a file, but it was not really the training data, and we weren't sure if it really was the file. And we had no idea what the requirements were the model was trained with. So we tried, and there was a requirements.txt file, but it didn't include everything. And that was a bit of a nightmare. And this is kind of my motivation for this talk. So what I tried to do, or what we tried to do after that, after we found this, we thought, okay, we can do a bit better. And we want to have it reproducible. So that if I run a machine learning model, or if I train a machine learning model, someone else that comes after me, or my future self even, can then recreate this experiment as it should be. All right, enter poetry. What is poetry? Poetry is a Python packaging and dependency management tool. It has a virtual environment management, and it has a dependency resolver. And this is the great thing. So what does this mean, or why is this useful? Let's imagine I have my app, and I'm developing my app, and I'm installing this package, and I'm installing this package. Turns out both of these packages depend on the requests library, but on different versions. So I can't really have both versions. I can only have one of them. And what poetry does, it makes sure that all of that this project can work with this version, and this can work with. So basically that this is one version. So let's say that all the projects appear to have the same version. That was very complicated, more complicated than it needed to be. So poetry helps you with this. So you don't have conflicts everywhere. Since that was a bit confusing, I'll give you a bit more basics and a bit more details around this. All right. So maybe as a quick introduction, this is how the project structure looks like it's just very compact. So I have my demo app, and I have a pyproject.toml file, and I have a poetry.log file, and I will tell you what these two do in a second. I hopefully have a README if I did good, and I have a source file where my code is there, and I have a test folder. So the pyproject.toml file, what does it do? It defines my main dependencies, and it also defines my Python version. So it says, okay, for this project, I decided to run this on this specific Python version. This is now rather fixed, but I can also say, okay, I want it to be just higher than 3.8 or something like this. And then I define my main dependencies. So for example, pandas. And I say, okay, pandas, I want this specific version. And all of these are in my pyproject.toml file. And this file is also committed to Git, so that if someone checks out the repository, they know which requirements I wanted to install. And then I'll share a little demo of how this looks like. So it's similar to how pip would work. So you can do poetry add pandas, like you would pip install pandas, and then it will resolve all the dependencies that are already in your project. And then it will install the sub-dependencies as well. In this case, it's NumPy and Pyths with the specific versions. And then you can see that in the pyproject.toml file, all of these are nice. All right. So once you've done this, you come to the poetry.log file. In this file, you have all your dependencies or all your packages that you had installed or that you have installed. Are defined here. They add a version and they have a description, and they also tell you with Python version they work with. So this just says, okay, it needs to be higher than 3.8. So if I decide to upgrade my package now to run with 3.9, this would also still work. And Poetry knows about all this. It also knows that it has NumPy, and NumPy needs to have at least this version. So let's say I install a different package, which is also dependent on NumPy. Then Poetry makes sure that both versions are happy. So that if, let's say, the other version says, oh, but I need NumPy 1.22. And And then it says, okay, I can also do NumPy 1.22, and I'll just use this one because Pandas also works with this one. I hope it's less confusing now. Once you have your files, you can run poetry install. And also if you check out a Git repository, you can just run poetry install. And if there is already a log file, it will install the log file with all the fixed subdependencies as well, or it will create the poetry.log file for you. How do you get started? You do poetry and then new project, basically, so the project name, or if you have an existing project already, you can do poetry init. So I would say quite straightforward and quite like most of the other tools that you can use with Python. Then maybe just a quick excursus to the virtual environment, because I use it quite a lot, and I do think it's quite useful. You can just open a virtual environment by running poetry shell, or you don't have to do that. You can also run just poetry run Python and then your script, which doesn't open a shell per se, but it runs your Python script in your virtual environment, which can be quite neat as well, in my opinion. Here I have a quick overview, just for the ones who are interested. So I've never used or never like thoroughly used pipenv, so I can't really say if that's a lot better or not. I like poetry. I heard that it's faster as well than pipenv, but if you have more opinions about this, feel free to ask them in the questions later, or challenge me, whatever, challenge the slide. And yeah, this is basically everything that you can do. And I also use poetry with PyEnv, just if anyone's interested. All right, the second thing I want to tell you about is DVC. What is DVC? DVC stands for Data Version Control, and it's a data and machine learning management tool. DVC runs together with Git, so you can use it together and alongside and besides Git. Git is there to store and version your code. So you have code and you want to version it and you want to share it with other people. That's why Git is so great and that we all know and love. And then you have DVC, and DVC is more or less the same for data and for your model files. And that makes sure that you have easy collaboration and you can reproduce everything, hopefully. All right, DVC Basics. I started again by showing you a little bit of the project structure. This is a bit more complex now. So you have a .dvc file, which tells DVC a couple of things it needs to know about this project. Then you have a data file where you can have your data. I don't think that's a requirement, but it organizes it a bit more. You can have a DVC plots file. If you want to compare plots across different versions, you can have this folder, and DVC knows that there are the plots in there, and it can combine them and compare them, which is quite cool. You can have a metrics folder where your metrics are stored. You can have, so this is all can, not have to. You can have a models folder to store your models, so they're kind of neatly organized somewhere. And I also like to have a notebooks folder because at some point someone always wants to run a notebook. So you can also have them neatly organized somewhere in your project structure. And here you can already see DVC works similar to Git. So you also have a DVC ignore file like you have a Git ignore file. And then you have a DVC YAML file, DVC log file, and a parameter file. And I will tell you more about these files in a second. All right, the version control. We said you have to use Git too. So if you have a project, you have to run Git init first, and then you have to run DVC, and you can run DVC init if you want to use DVC. So Git, you also have to tell where your code should live. So you say, okay, it's going to live on GitLab or in GitHub, wherever you want to store it. And similar to that, you also have to tell DVC where you want your data and your model files to live. So here I'm saying, okay, I use GCS and I want it to be in my bucket. So I'm just telling DVC, okay, I want you to store everything in there. and then it also version it there. What you then need to do in order to version a file is similar to Git. You do DVC add and then your file. And what happens then, it creates a second file, which is called myfile.csv.dvc. So this is a newly created file. And this is just a reference to this file. And it will tell your computer where it can find this file. So the idea is we're going to store the actual file somewhere else than we do the Git file. I think that kind of makes sense. So you have your data somewhere and you have your code somewhere. And this is your reference file. And you add this. And what also happens is you have a git ignore. And in this git ignore now is your actual file, because you don't want to commit that to Git, because we don't want to have large files in Git. And then you say, okay, like you would do, you would commit this, and then you would DVC push. And what DVC push does, it pushes your CSV file to the remote storage that we defined earlier. And then you can do git push. And if now someone goes ahead and does git pull and DVC pull, they will download data because they have this lovely .dvc file, which told it, oh, you have a file available in your remote storage and you can download it if you want to. All right, I have a quick demo here too. So here we have a poetry project, as you can see. And so we're opening a shell. And then we're going to look into the data folder. We have a file there. So we're going to add this file to DC. And then you're going to have two files, as you can see in a second. So if I look into my data folder again, here you have a csv.dvc file. So this is our reference file to the other file. And then we want to add this one to Git, as well as the git ignore file that was created also in our data folder that told Git to ignore the actual file. So we have this. And then we want to commit this and push it to Git. And we want to push the file to the remote storage. So this first, then DVC push to push the file to our remote storage. There we go. It's transferred and pushed. And then you do git push to push all the reference files so someone else can then download them again. I think this is a really pretty nice workflow and relatively easy, I would say, as well. All right. The next thing you can do with DVC, and that's pipelines. So another thing that we had when we inherited this project, or this machine learning project, was that we weren't sure what was run actually. So for machine learning projects, you normally have pre-processing steps. So you want to do something with the data first before you train your model. So let's say you have a pipeline, like a machine learning pipeline kind of, and you want to pre-process your data first, then you want to train your model, and then you want to also see how it works. All right, so we have 3 steps. And what we can do with DVC is we can define a file in this dvc.yaml file. And we can say, okay, I want you to have several stages, and I want to define in which order they are run. So here you see I have a pre-process stage and I have a training stage. All right, and for each stage, I'm going to run this command. So here I say, okay, this is a Python file. So I'm going to run Python and then my file. And then it's going to be executed in this step. And this step depends on this data. So my first step depends on a data file. And as you can see here, after it depends on this data file, the output of this stage, so what comes out of this, is a labeled data set. And this here, the second stage, depends on my labeled data set, because in order to train a machine learning model, I need a labeled data set. Right, and this is also how DVC knows that this stage needs to run after this stage, because the output of this is the dependency for this. And the nice thing actually about the outputs is you don't need to add them extra to DVC if you do DVC push, and so if you run this and then do DVC push, they will be automatically pushed to your mod storage, and someone else can then download them from there. So if you run DVC repro, which runs the whole pipeline, you have first your preprocess stage and it runs, and then you have your training stage and it runs. And then let's say I've run all of this and the preprocess stage takes 5 hours to run. And then my colleague only wants to change something in the training file. He can now go ahead and download it again, like git pull and DVC pull, and then change something in the training file, and then run DVC repro. And then DVC knows that the preprocess stage actually didn't change. So the output file, so if it would rerun the stage, nothing would change. So it already knows, okay, didn't change, I'm skipping this, I'm only running the training stage. And this saves also quite a lot of time, or for me at least, this saves quite a lot of time sometimes. The last thing you can do with DVC is track your experiments. So you can say, I want to see what happens if I run my model or if I run 2 different algorithms. So I can run it with a linear SVM or a linear model. If that doesn't say anything to you, it doesn't matter, 2 different algorithms. So I'm going to say, I want to run an experiment, and I'm going to set a parameter for my model training. And I want you to either run it with this, or first run it with this, and then with this. And then it's going to run them, and it's going to run them in 2 stages. And then I'm going to say, okay, now that you've run this, I want you to show me the experiments. And here you go. Here is a little table, and you can say, okay, this model led to, so basically workspace is the last thing you have committed. Main is the actual thing that's in the remote git. And this is your branch name and your experiment ID. And here you can see the different parameters I have. So I have a pre-processing parameter and a training param that you just saw. And then you see your accuracy and your recall, and you can define all of that. 5 key takeaways for reproducibility of your projects. First, poetry that we had first helps with the Python dependency nightmares that I have. Poetry also makes sure that everyone has the same package installed, that everybody has the same sub packages installed, and that everything works nice, nice together. DVC stores your files and makes them accessible to others, just like you would with your code with Git. Also, DVC can make sure that all the ML steps are run in order, and first of all, also that everybody knows in which order they should be run. And DVC makes sure that the results are stored and accessible to others, and also that they're cached in a way that you don't need to rerun everything all the time. That was it. If you have any questions, that would be nice. Otherwise, thank you very much for having me here.
Hi. Hi, Doreen. Thank you for the amazing talk. It was so lovely to learn those things. We have a couple of questions on Slido. Maybe other viewers also would like to ask, but in the meantime, I can just go ahead and ask those questions. So the first one is that you mentioned that poetry is faster than pipenv, and we should challenge you on that. So respectfully challenging you.
So also I've read up on this a bit, and this is what people say on the internet, what people say things on the internet. I actually don't know, and I haven't found any real benchmarks. I don't know if you have any, but yeah, I haven't found any benchmarks, just opinions on the internet.
Thank you. Next question is that can you give an example about the problems that we might have with pip?
So things that actually happen to me is that if you have sub-dependencies that don't work well together, and you don't realize, then it can happen that, so pandas, for example, tries to import something from NumPy, and then you don't realize that you installed a different NumPy version that actually doesn't work with your pandas version anymore. And this leads to very weird errors that you might not notice directly because it's some kind of import, somewhere, and it might not be a tested code. And you will not realize until you hit that point in production, and then things fail, and then you need to figure out why, which can take quite a lot of time.
Thank you. Moving on to our next question is that why we are running Poetry shell before running our comments?
I just like to do that. No one needs to do that. So you can just use Poetry run and then this. I kind of like to have it because I don't need to run Poetry run before everything. So I just like it this way. But it's more personal preference, I would say.
Yeah, and both Poetry shell and Poetry run is activating the virtual environment. So this might be one of the reasons. How complex was it to onboard the team to DVC? Did you already have experience with it?
I had a bit of experience with it. My colleague didn't, but he was super on board. So it was, at this time, it was just the two of us working on the project. And I suggested it, and also like since we had this whole nightmare before, it was actually quite easy to say, hey, there's a tool we could use. And then he was fully on board and like did a lot of the stuff and read the documentation. And it was actually super easy. Like it's not incredibly complex to use.
Thank you. Next and final question is that which sources do Poetry uses to install packages? For example, with Conda, we can use Conda Forge as source or add anything you want. Is it possible with Poetry?
I'm not very, very confident in this question. If you know also a lot about Poetry, so maybe you can answer. You can definitely install Git, just Git paths as well, and normal folders of projects and all the paper packages. That's everything I know. What do you know?
Yeah, for this special questions, I'm not also very comfortable, but I can say that for anyone who's interested with Poetry and pip and which package manager that we should use, I will be giving a talk about this specific topic, dependency management in Python, and we'll be comparing pip, pipenv, and Poetry in our June talk. So if anyone's interested, maybe they can join.
Really excited.
Yep. Well, that's it. Our questions are done now. Thank you so much for the talk. It was really good. And big round of applause for you.
Thank you very much for having me. And thanks for the questions and the introduction.
Thanks. Hi. Now we have our next speaker. Radvan is here, and he is a software developer mainly focused on Python and backend services. Big round of applause for you as well, Radvan. But before I let you take the stage about concurrency of Python, I'd like to mention that questions for you will have to come from Slack and not Slido because we won't be having enough time. So enjoy.
Thank you. Hey folks, welcome to my talk, Python's Tale of Concurrency. This is a general introduction to concurrency through the lens of a Pythonista. If you're someone new to the concept of concurrency, you are the perfect audience for the talk. I hope this talk excites you to explore the paradigm of asynchronous programming and gives you a solid background to tinker on your own. Just a bit about me. I'm a Python enthusiast. I love the Python community. I love all things open source, and I try to give back as much as I can. I'm a backend developer by profession. I build backend services and internal tools using Python. So let's get started. Let's start this talk by understanding what concurrency actually is and why anyone should explore this paradigm of programming. Let's build a hypothetical service around coffee and call it as coffee as a service. So why not? So how this service works is the user comes in, requests an order, waits until the order is prepared, and once the order is completed, the second user gets the access of the service. So the whole user flow now becomes order, wait, move, and continue. Now with passing time, our service gets lucky and we start to get a decent traction. But we notice a few complaints here and there. The complaint that the service becomes a bit slow when you get a lot of users, which is true because service would be as fast as the slowest order in a queue. And when we get a lot of users, the chances of slow orders also increases. Realizing this problem, we set out a goal to fix this problem. This is where the concept of concurrency comes into picture. Wikipedia defines concurrency as the ability of a program to be executed out of order or in partial order without affecting the final outcome. Or as Rob Pikes puts it, concurrency is about dealing with a lot of things at once. If you look into a real life example, one really good example that I couldn't find is of a hurdle race. The athlete is running and jumping, not doing both at the same time. Coming back to our service, now that we have a brief idea about what concurrency is, let's see how we can use it to solve the timing problem we have. What we can do is we can add a barista, and that barista can take future orders, even do preps for them while the first order is being made, which would eventually decrease the wait time for the users. If I talk more in terms of programming, we can say that barista in this situation acted as a scheduler for the service, but more on that later. Another obvious way to solve this problem could have been just add more machines to it. That this solution would be correct, and in programming terms, we would call it as parallelism. That's a different tale for a different talk, but in this talk, what we can see is how concurrency is different from parallelism. Concurrency is a slightly broader term than parallelism. In concurrency, multiple tasks have the ability to run in overlap manner, whereas parallelism, they are executed at the same instance. One is about structure, the other is about execution. Now that we have a basic state, let's see how Python handles concurrency. There are primarily two ways in which Python handles concurrency first is through a threading library by creating threads, and the other is by taking advantage of the async library. Moving forward in this talk, let's tackle a very trivial problem. Let's fetch XKCD comics and let's fetch them for a certain comic numbers and store the data. This could be very trivial and let's store it in a list. And let's just try to solve this problem in two ways. The first solution would be a sequential one. The second solution would involve us using concurrency. That way we can compare and see what concurrency is, how it's different than sequential programming, and how Python handles concurrency. So let's create a getComic method, which is a very straightforward function that makes a get request to a particular URL of a particular comic number, and if we get a 200 on the response code, we just store that data. So the rest of the code would look like this. For simplicity's sake, let's just use comic numbers in a list and iterate over them and call our function. So that's our first solution basically. It's simple, gets stuff done, and is sequential. That is, for every request or every comic number, we would have to wait for the second request or the first request to be executed. That way only we can move to the second comic number. That is, for the comic number 10, the only way it could move forward is if comic number 10 gives any of the status code. Could be 200, could be 500, anything. So if we time our program, we can see that it basically takes 1.84 seconds. And before moving forward to our solution, let's just first understand about threads. So Python threads are implemented using OS threads. The interpreter runs on the main thread and on demand can spawn a separate flow of execution or threads. IO-bound tasks are the best use cases for threads because of the global interpreter lock or GIL. Only one thread can run at a time. Let's look into a simplistic thread execution to get more clarity on this. So if you can see here, when thread 1 is running, it acquires a lock or the global interpreter lock and makes a request. In the meantime, thread 2 has to wait for thread 1 to release the lock, then only thread 2 can execute. So this is kind of simple when we only have 1, 2, or a handful of threads, but it gets way too difficult as we add more threads to it. So using the threading module, how we can tackle our first problem is we can utilize the same getComic method, but while iterating through comic numbers, what we can do is we can create a separate threads list on line 4 that would store the threads instance, and on iterating over comic numbers, we can pass the getComic method as a target to the thread instance and the argument, that is the comic number, which you'll see on line 8, and we can append that to the threads list and we can just start the thread. So one final thing now for our program to run is join. Calling a join on a thread instance waits until the threads terminate. This blocks the calling of other threads until the threads whose join method is terminated. Join also accepts a floating point number, so you can decide how long you want to block that thread, ignoring the threads that aren't ready. So if you decide to set a timeout value, you would need to check if the thread is alive or not. If the thread is alive, or on line 6, if thread dot is alive is true, that means join on a particular thread instance fails. Hence, we've used the not on line 6, removing all thread instances that pass. And if you don't want to get into the hassle of start and join, you can always use thread pool executors. Thread pool executor uses a pool of threads to execute calls asynchronously. Using it with a context manager on line 11 that you can see makes the thread automatically call the join method. So by somehow you're not stuck into that start and join hassle. Finally, when we run our program and compare it with the synchronous version, we can see that the threaded program is much faster. But one thing is here, if you run the program multiple times, you would see the ordering in which it is fetching the comic numbers changes every time. This is a common problem when using threads. Since our operating system is responsible for context switching, we as a user get a very little say in when it's come to ordering. So we can't technically predict which comic methods will be fetched at which state. Now moving ahead, let's learn more about async IO. Another way in which you can write concurrent code is through async IO. Async IO utilizes the power of event loop and executes function which can be suspended when they need to wait and restarted when the wait is over. Most of the programs written with async IO are single threaded, and it utilizes, and the user has the control of context switching, thus calling it cooperative multitasking. Since async IO tackles the problem of concurrency in different manner, it also introduces some new jargons. Let's understand each one of them one by one. Async functions. Async is a keyword to define asynchronous functions. Normal functions are blocking in nature. That is, they stop the flow of execution until they return something. Since in a typical async IO based program, everything runs under a single thread and all functions are executed by a single loop. Thus, to be concurrent, those function needs to be non-blocking in nature. That's why the whole async keyword was introduced, so we can create those asynchronous functions. Though, if you notice here, on line 5, I've used asyncio.sleep rather than time.sleep, just because time.sleep is a blocking call and asyncio isn't. With time.sleep, you don't return the control flow to the event loop, and you will hold up everything and nothing else can happen until the time is passed. Seeing this, you must have realized by now that if you're writing concurrent programs with async IO, you might have to ditch some of the standard functions and use the ones offered by async IO. Coroutines are basically awaitable objects that are created with async functions. Here on line 8, if you could see, coro is a coroutine, which further is made clear on line 10 by printing its type. Coroutines do three things very commonly: wait for the forthcoming results, await another coroutine, or return a result. Most folks commonly interchange async functions and coroutines. So here's the distinction. Lucas Langa gave this neat little distinction between async functions and coroutines, which I find very useful. That is, async functions are the definitions, where coroutines are awaitable objects. So coroutines are awaitables, but async functions are not. Moving it, the heart of the program that uses async IO is the event loop. The only job of it is to schedule callbacks and not actively wait, so we can concurrently run our program. Python allows you to directly use the loop object, which you can see on line 2. So we can, by the help of get event loop, and if we print it, you can see the information regarding the event loop. The ability to use the loop object directly gives you the freedom to use libraries that only support async IO or using an event loop. One such project that I could think of is PyPuppeteer. So what if you want to use PyPuppeteer, but your entire code base doesn't require an event loop? In this situation, what you can do is you can create a loop. You can spawn a separate thread, create an event loop there, and use and in the event loop use the PyPuppeteer library. Though most of the time you would be dealing with high-level functions called async IO runtime. So if you require an event loop, your program would just use an async IO.run, which is kind of an elegant way of getting the event loop, running all the tasks that are needed, and closing the event loop. The one very interesting thing that Python gives you is the ability to make a drop-in replacement of the built-in event loop. One very good example of a pluggable event loop is UV loop. It uses Cython. And Cython is built one very good example of a pluggable event loop is UV loop, which is built on Cython. So using UV loop and async IO combined can give you a very high performance networking code. Now that we know enough about async IO, let's use our knowledge to write some function of extracting comics with async IO. So here you can see is instead of request, I've used stdpx and I've created that getComic method into an async function. And on line 7, I'm awaiting the client, the HTTPX client, asynchronous client for the response code. And rest of the method is just the same. So rewriting a main function using async client. So I'm using a context manager, and now within that context manager, I'm iterating over those comic numbers and awaiting the getComic async function. And async IO and using async IO's run high-level methods, so just calling the main function. So if we run this, we would see something strange. Even though we ran it with async IO, it's kind of slower, and it's not. This is because if you go to line number 7, you would see so this program is kind of being very sequential, even though we written it in an asynchronous manner. This is a very common pitfall that most of the people make when starting out with async IO, and it brings us to our next topic called tasks. Tasks are used to schedule coroutines, and when you wrap a coroutine with that task, it independently gets scheduled for execution by the event loop. So just like a previous example, even though we were running it with async IO, we still forgot one major thing, that await blocks the execution. So if you want to await on multiple coroutines, it's best to use the async IO gather method and pass all the tasks to it. Now that we know how to fix our last problem, let's see the updated code. Now, instead of awaiting on every response of getComic, on line 7, we are using a comprehension. So creating with async IO.create and using a list comprehension, we are creating a task list that stores all the tasks. And instead of awaiting on a particular task, we are just passing that task list to the gather method, so it can schedule those coroutines independently without blocking the flow of execution and making it pure asynchronous in nature. So if we time that program, we can see a significant decrease in time, which is much faster. So async.io is definitely a robust solution and makes writing concurrent program that are IO heavy easier, but it's easier to get into the false sense of security and underestimate the complexity that it brings to us. I still want to iterate to a point where concurrency is still hard of a problem to deal with. With this introductory talk on concurrency and the time limit I had, I could only scratch the surface of what there is to concurrency. There is a lot more in store when you actually tackle real world problems with concurrency, and sometimes adding concurrency to the mix of already hard problems like debugging, testing, profiling, it even gets more harder. So I would say don't treat concurrency as a silver bullet and make smarter choices. So before ending this talk, I'm going to leave you with some resources from folks who have very good hands-on experience with async.io. First is from the PSF's developer in his residence, Lucas Langa. Lucas has created a great series of async.io videos, which already has 6 episodes out. So feel free to check them out on HDB's YouTube channel. Second one is from Linroot. It's a blog post series which tackles real world problems with async.io. Though one thing to note here is these resources are quite comprehensive, so I would suggest to work with them on your own pace. That's all I have for you today. I hope this talk gave you a solid ground to tackle concurrency and to tinker with it on your own. Before ending this talk, I would like to thank Lucas Langa for his efforts towards asynchronous programming style in Python and the amazing video series on async.io. To Linroot for the efforts towards increasing diversity in the community through PyLadies, and for all the well-crafted and insightful tutorial series on async.io. And finally, to PyLadies Berlin, organizers, volunteer speakers, for organizing such an amazing virtual meetup. Due to COVID, I had to move to my home where we don't have much of the growing Python community here. So it's always fun to attend those virtual meetups. And finally, thank you all. Thank you for attending my talk. I hope this gives you a good understanding. I'll be posting all the resources that I was talking about on the PyLady Slack channel. So it's much easier for you to look at them. Thank you.
Thank you. Amazing. Thank you so much for sharing this with us. And I was going to ask if you would be so kind to share those slides in Slack, but you already said that you were open to that. And great that we could have speakers from really anywhere. I know the time difference was maybe a little less ideal, but thank you so much, Padvan, for your time and for joining us.
It was really fun.
Yeah, really enjoyed it. Both talks were amazing. And as you heard, we have next time also another poetry and dependency focused talk from Ukas. So we're really excited about that one. I also wanted to just say thanks to Fan, who's also joining us here on the stream, who's been in the background helping with slides and checking that everything's running smooth.
Thank you very much. Such a cool meetup.
Yeah, thank you, everyone. And wishing everyone a great rest of the day, whatever time of day it is for you when you're watching this. And we look forward to sharing more with you next time.
Thank you.